Welcome to the Tech Connect podcast. I'm Jason Martin, and I'm joined today by JC from the SoCal Tech Forum and Eugene Wang, CEO and co-founder of Fitasy. In today's episode, we're going to dive into how Fitasy is leveraging physical AI to manufacture highly customized footwear, the operations behind automating end-to-end workflows, and how this cutting-edge technology can help drive growth in additive manufacturing. Thanks for joining us today, Eugene.
Thank you, Jason. I'm also very excited here with you and JC.
Great. Now, to kick us off, we actually met Eugene when we attended CES this year. Is that correct, JC?
Yeah, that's right. First of all, I'm happy to be here, and I'm glad you're here as well, Eugene. Welcome to the SoCal Tech Forum podcast. And yeah, I mean, really, Jason, we went out to CES 2026. We went out to the entrepreneurial startup exposition at the Venetian. I was walking down the rows, and then I saw a bit of a crowd at Eugene's booth. I saw a couple people demoing his product, and then we just kind of kicked off the conversation.
Yeah. Thank you, JC. I feel lucky to know you at the CES. It's such a crowded
Thanks,
place,
Great. So, Eugene, why don't you kick us off? Tell us a little bit about yourself. Tell us, about your background, how you got into the manufacturing business, what brought you specifically to manufacturing footwear. I'd love to hear about it.
Okay, thank you, Jason. I can keep it brief. My story could be very long, but I will keep it brief. My name is Eugene, and I was born in China. I get my bachelor education in China at about 2009. I get the opportunity to study at the US. So about 2014, I get my PhD from MIT in the field of mechanical engineering and computation. After that, I spent about a decade working in the US automotive industry. About 2 years ago, I see Industry 4.0, smart factory, all this timing is right to change many industries. So what I'm saying here is AI for industry. So that's the place I started the company Fitasy. It's about a little bit over than 2 years now.
Very cool. So, was there a specific aspect to AI that really called you over to the manufacturing and Industry 4.0, or what was it specifically that called out to you?
Yeah, it's kind of related to my research when I was an industrial scientist. We do a lot of nano level and micron level 3D imaging. Then we build a physics-based model to do simulation based on the 3D model. I think the key objective is understand the physics in the industrial device. In that way, we can design better product for the customer. In that field, I see Industry 4.0 already is a reality for the automotive and aerospace, industry. But it's not happening much in other industry. If we apply this technology, especially the AI, here I'm referring the spatial intelligence or 3D AI. In some area, I think they can bring big change and make a much better product for everyone. So that's the opportunity I'm excited about.
Very cool. And you've taken this technology and you've applied it to your company, Fitasy. So tell us a little bit about, what Fitasy manufactures and how you're kind of changing the game for that space.
Yeah. Actually, the story, is kind of interesting. Initially, we only have a very abstract idea. The idea is, I think if we put a digital, driven production in some industry, it could brought some change. But when you start a company, you want to be very specific. You want to solve a pain problem. You want to give people a better product. From my perspective, 3D AI, spatial intelligence, is the area we think can make a change in any manufacturing area. One, as a consumer, I do have some pain point. For example, I have wide feet. I have a problem to buy comfortable shoes. Then I study this problem. Why don't they make multi-waist shoes for everyone? Or even to some level, make a customized shoe available to everyone. The result from my research is if you look at how the footwear industry works, There's company own the brand, they control the design. There are also other company overseas, they specialize in manufacture. The typical time to develop a new shoe is about 18 months. The cost is about $2 million. And if you look at the manufacture process, is basically is the production line invented like 200 years ago, right? And there's some molding machine, there's some cutting machine. But if you look at all this process, it's very rigid. It's very hard for you to change the diameter, the parameter, dimension of the product. So that's the reason they only relies on one average foot model and have fixed size for everyone. So basically, it's a product for millions of people. Even millions of people, they have a very different feet. So that's the one area I see. Well, if you have all this digital technology, and if you have a manufacture system can be powered by this digital system, and that will change a lot of things.
Yeah, absolutely. And the manufacturing process behind it is incredibly important to make it, scalable and match customer expectations with turnaround time. So really excited to dive into that part in a bit. But you're absolutely right. I mean, my own experience going out and buying shoes, every brand has their style and how they manufacture them. Some are like very flat-footed, some are wider or narrower, and having the ability to customize any shoe based off of what you like the style of can be a complete game changer. So that's exciting.
Hey, Eugene, I actually want to revisit your origin story because if it's one thing I thought when I went to your booth, I thought it was a little weird. I was like, what? I was like, nobody's doing this. This is a little bizarre. And that was part of the intrigue too. Like, not just your design, but just your concept as well. So
Mhm.
you told us a little bit, like, could you dive in? I know you said your pain point, your own feet. Were you like at a shoe store when this clicked? Because you have this very impressive background. You have all these resources. You have all this knowledge, this emerging technology you're aware of. And
Mhm.
then what made you hone in on that specifically? Because you're right. The riches are in the niches, right? You kind of honed in, but more on your like hero origin story, villain story, whatever. Could you
Yeah.
could you enlighten a little bit more on that moment when you had that like light bulb?
Yeah. So I can be a little bit more specific on this about the AI. We are very interested in the spatial AI. That is like how to deal with the 3D data, including the process, how to get the 3D data, how to, understand, transform them, and how to use that data to driven the production. So from that regard, we see many areas could apply this technology. One example already, manifested itself is the dental industry. If you see some printed dental device, this is based on some dedicated scan device. They can stick inside your mouth, get a 3D morphology of people's feet, of teeth. And from there, they can generate a customized assistant system for each person based on their 3D morphology. I think that area, everything is proven. And we see what's the second area could need these technologies. When I say this technology, it could be easy to get a 3D data, ready to transform the data and use that data to power the production system. And we identify footwear is a field that could be the second area to use this technology. Why is that? Because everybody is very different in terms of feet. When you make shoes, you always say you don't know others until you put your feet in other people's shoes, right? This is need precise engineering, right? The feet also needed to be very personalized. If you wanted to be dive in more, the biomechanical thing also be well tuned for each person. So that's a place I think after dental, footwear could be area needed to be applied precise engineering, you
So you
That's
saw a gap in the marketplace, and you went for it, huh?
know.
yeah,
Great. So
that's interesting. It wasn't something that you necessarily stumbled on, but rather like it was precise engineering. You distilled it And to Jason's point, like you found that gap. That's wild. That's interesting.
Great. So why don't you tell us, Eugene, a little bit more about your shoes? I think they have an interesting design, and I love the sustainability story that you have behind it as well. So maybe you can dive into that a little bit.
Yeah, if you guys don't mind, I would like to hold the shoe in front of me. So
Nice.
this is a fully 3D printed shoe using one material. And we also call one process. Basically, the shoe is built vertically, layer by layer. This is the digital laser pattern projected into the solution. Each layer structure can be separately projected on the solution. And this is a light sensitive material. It will be cured once they see the laser light for about 0.1 seconds. In this way, once the layer is built, it move up, then they build the next layer. This is how this technology works. And one very unique feature of this, you see lattice, we call it a lattice. Maybe it's not the lattice in the physics, chemistry terminology, is the small grid I'm pointing to right now here. So actually each this lattice is a mechanical spring. Its stiffness and its strength can be separately tuned by changing the diameter of the fiber or density of the fiber in certain region. So that will give you any cushion or sensation you would like to have. So that is what I'm talking about, the digital driven. If you know exactly what you want, and you can build the shoe just by sending that file to the printer, one click, the shoe will come out. And about, another digital driven, if we scan your feet using Fitasy app, we get your 3D full model. We generate a customized design. We will change the internal volume based on your foot morphology. So that is we call customized shoe. That's what JC probably see our scan demonstration at the CES. And in terms of the recyclability, if you look at the traditional shoe, why is not easy to recycle? I think there are basically two problems. One is some material like a glue, like some rubber is itself is very hard to recycle. The second is they are using many material. They glue them together. Economically, it doesn't make sense to tear them separate because you cannot use this material. So sadly, the common way they are directly thrown into the landfill, which is cause environmental problem. For this shoe, things much, much easier because it's only one material. You can shred it, it come to pellet, a small particle, and this particle could be recycled by two ways. One is they call downcycling. It's basically you can using this material to make a playground, a running track, even some home used stuff. Just using this plastic, pallet to make something have a cushion. The second one is if you're using certain catalyst, go to some chemical process, this material can be go back to the upper chemistry to make them. From there, they can ready to make everything else. So this is like a polymer molecule. So that's the two way to recycle this. And probably if we have this shoe at the end of life, you return to the right factory. The easy way is mechanically break it down and then build some playground. That's the easiest way and the most economical way right now. Yeah, hopefully my introduction about the recyclability is helpful, JC.
No, it is. It's actually you're blowing my mind because I'm thinking about how shoes were made in the past. Bespoke shoes. You take a mold, and then they even carved one out of wood, and then they stretch the leather on top of that. And you're able to do that with the spatial intelligence. So I'm kind of curious into the next question because I did get to see the app, and it was awesome. I thought it was really cool. It was intuitive, like take the next photo. It kind of prompts you. That was the front end. What's the back end look like? What's the whole end to end sequence? And how do you, I would say maybe automate, or how do you make sure or keep that so that it's scalable, opposed to one person reviewing every single input, right? Every single time a person scans for a shoe.
Yeah. So if I understand you correctly, you would like to know the end-to-end process
That's
about
exactly
our
what I'm.
customized
Yeah.
personalized shoe. Okay. I think that is something we call a three-step solution. First is to get the customer feed data. I think you try our app
I did.
at
Yeah.
CES. Now it's available in the Apple Store. It's called Fitasy customization. So first time use it usually is some learning curve, but the idea is very simple. You just scan your foot from 5 angle in 2 different state. When I say 5 angle is bottom, front, back, inner, and outer angle. When I say 2 state, when we scan your foot bottom, your foot hold in the air, that's a no weight bearing state. When you step your feet on the ground, that is in weight bearing state. We scan your feet from 4 different angles. Actually, I'm not sure whether you guys pay attention or not. Many people, almost everyone, their feet are different in the weight bearing and the non-weight bearing state. Usually for many people, that means at least 3 to 5 millimeter difference in length, a few millimeter difference in the weight. That is something is harder to correct for the feet scan. Just to figure out one state is easy, but this is a living matter. It changes the shape when you walk and when you rest. That is a step one. Get the customer 3D data accurately. Once the data is captured through our app, the data will flow to the AI system in our cloud, and we will take a look at the 3D data because this is the feed. It's much easier to have a general intelligence to look and understand everything. But here we make it a problem manageable, right? This we confine to the foot problem. We will identify the feature and the 3D morphology of the feet. From there, we get the length, width, arch height, and the girth data, right? Based on this data, we will generate a custom design for the feet data we receive. And the third step is about ready-to printing. With that custom design, we will generate a custom printer file for that person. If it's an FDM printer, maybe that's a G-code file. If it's for digital light printing, that's a different type of file. But basically, this is a ready-to-print file. We don't do printer. We don't do printing material. Our job is get the custom design, printing file ready. One click, that should could come out with any compatible printing system. Yeah, I think that's the general 3 steps how the technology works. And if you think about this, forget about the one click, push the button, from the scan to the cloud system, massage, transform the data to generate the ready-to-print file. This is happening in digital world and can be fully automated. So that's the way we make it scalable, right? Yeah.
Very nice. So everything from receiving, so what I'm hearing is everything from receiving the data from the initial scans, all of that is being transformed and adjusted by the AI into your printer files that you need. And then there's like a human validation step to get that over into the printer and making sure that it's all accurate before production. Is that correct?
Right now, our goal is don't have any helmet,
That's amazing.
interference in the system, but we do already have a validation step. Make
Yeah.
sure the thing work as the way it's supposed to. Yeah.
Great. That's amazing. So what type of volume are you able to do at full scale through this process at this time?
So in the digital world, basically, there are not much limit. But for the physical world, that could be a problem. We have a certain amount of printing farm and a printing factory sign contract with us, right? And based on the contract we have, I think every month, like 2,000 pairs is possible with us.
That's amazing.
Yeah, if beyond that, we're happy we needed to find more printing factories. Yeah.
That's a good problem to have.
Yeah.
Wonderful. So, talking a little bit about physical AI and its impact on the industry. So, with physical AI coming in, I'd imagine there's a huge application here for part manufacturing, R&D, all of that for additive manufacturing. Like, how do you see this getting applied more broadly as the technology continues to mature?
I think physical AI is a buzzword right now. And before we touch this word, we wanted to understand something like ChatGPT. I would call it is a language AI, right? It understands the token of language. And if you look at even the AI before ChatGPT, AlphaGo is the AI understand the Go game rules and acts in that space. So to my definition, the physical AI is the is artificial intelligence system that can sense, understand, and act in the real world environment. That could be very broad. It can be robotics, could be autonomous driving car. Okay,
Hmm.
we don't want it to be diluted by this one. We are focused on the 3D spatial intelligence.
Sure.
So the AI can understand the 3D world, can make sense of them, can design something useful based on the 3D data and the power of the production. So, so physics AI is very, very, I think is very interesting and challenging. And once we are there, I think the humankind definitely will have different capability with the help of physics AI. Yeah.
Yeah, absolutely. That's amazing. So, in the area of additive manufacturing, one of the thing, reading up on this, the industry and the growth trends, like it sounds like the industry in general is blowing up. I read one article where it was expecting, over an $88 billion industry by 2030. So, do you feel that, in the market in general, due to various different pressures with cost of material. Do you think additive manufacturing is going to continue to grow, and do you think that's going to eventually be, a big chunk of how manufacturing is done in the future?
Yeah, I think absolutely. Most of the printing technology is just like, it's not like invented like last year. Actually, they are invented a long time ago, could be 30, 40 years old, for example, right? They have been fumbled in some way for a while because uh, they needed time to make the material mature, make the system robust, and more important, they needed a scale to be large enough, make this whole thing become physically, economically feasible to make things, right? Recently, if you look the printing market, especially the FDM printer, they are widely popular these days. I went to several friends, garage. All of them have a printer in place. That is amazing to me. Yeah. And if you look the industrial space nowadays, I think in Asia, also in Europe or North America, there's a concept of printing farm. They have some, consumer-based FDM printer, and they also have some industrial level larger printer. y- one device could be 500,000. They take up very large space. They need a dedicated, air compressor, industrial cooler, all this device. I think they make sense in the industrial place. I think mainly for three reasons. First, some very complex part is almost very expensive to mold or other way to make it.
Hmm.
They can easily made by 3D printing, especially in the metal or powder printing area. The second is, if you look at the whole system of the printing right now, right? The 3D printing itself can give things very high quality. If you look at their surface, now it's very fine, right? The third thing is the scale. When they go up, the price is very, very friendly. Some level is more competitive than injection molding, for example. I think just take us, for example, we see the printing cost this year is 20% less than last year. just to the scale difference. So if I foresee the future, I would say in the next 2 or 3 years, maybe even 10 years, the price will continue reduce at such pace. So in that way, the whole thing become very competitive. So that's one of the reasons the 3D printing market is increasing, right? I think secondly, it could be a toy for everyone, right? I know some kids, they printing some toys they download from the website and they sell in the school. My son bought one. I'm amazed by people can actually, including kids, can making money by using 3D printing technology. Yeah. I think economically it make more sense. The main reason I think it's get so popular is allow people unleash their creativity, right? So 3D printing is a magical device. Once you define what it looks like in the digital world, hopefully it's not too big. If it's too big, you can scale down and fit it into your printer and you can make it. So in that case, imagination is the only limit we have. Secondly is you can easily tweak the dimension. I think that's so-called, I think it's well known in the industry. 3D printing or similar technology is the only way to democratize personalized production across the world. So that is something people maybe hope to have. Thirdly is you can print it at home. So if you need something like I talked to the friends, they work in their garage, they may need a part. The easiest way is not to buy from Amazon or any other place. They have that digital file, they print it and no shipping, no waiting. If you're not happy with it, you just tweak the digital file, you print another one. So that is all the benefit of 3D printing give people. I think that's my way to understand why it's so popular and will continue to grow in the future.
That's amazing. Yeah, and I've heard of manufacturers now, even as part of the support section, being able to provide, 3D printer files for manufacturing your own replacement products. If they have a small, plastic piece that tends to break on their product, they'll just offer, the file for you to print your own replacement at home versus having to support, sending out the replacement piece and dealing with the support side of things. So I think there's a lot of applications there that can improve the experience overall.
So that kind of leads to a question that I had, like traditional manufacturing and then the personalization, right? You mentioned that traditional manufacturing can take up to 18 months and what was it, like $2 million to come up with a design?
To develop a new shoe.
That's wild. Um, what would you say are some of the challenges and additional advantages of the customization route that you're going? I mean, 18 months and $2 million, like that's a big win over traditional. What are some of the challenges that you face in personalization?
I think the challenges is the whole transition is just to get started. If you really compare 3D printed shoe, I think to be honest, there's some disadvantage. First is the cost. I'm saying the cost is already 20% lower than last year, but if you look at the 3D printed shoe, they are still more expensive than a traditional shoe. I think that is one. Second is if you look at the 3D printing technology, there's some limitation of the material choice. In the FDM, you only have certain wire you can buy from. In the digital light printing, you only have certain polymer you can buy from. Compared with traditional, you have different kind of fabric, leather, you name it, all the material. You can glue them together. You can double layer of them. I think that's some two major limitation to me. But at the same time, it gives us the huge freedom at the same time. For example, if you easily allow people to have customization or personalization, I think first about the customization is it would be a much comfortable product than the standard size. Secondly, about personalization is I don't know whether you guys have the experience or not. My wife used to buy my clothes from Costco when I go to work. I see two guys or three guys wear the exactly same t-shirt from the Costco. It's kind of awkward. I think that is in the bottom of our heart. We want to be different, right?
Yeah.
And if you more than that, you want to do self-expression through the thing you are using, I think if you buy from Costco, probably not good way to differentiate that. But if you do 3D printing, you have a certain level of freedom to change the design. You can easily to impress anything you want to share with the world. Yeah. And I think there's another big benefit of 3D printing or any related technology is the whole production system is very different. It starts with the, specific data set driven the production. And when the product is done, is sent to the customer. If we have a loop to get a customer feedback, you can turn the whole system into a big learning process. Initially, they may be only a little bit better than the existing solution. Sooner, they will be better, right?
Wow,
Much
that's
better.
amazing.
And in a longer time, as you get a more user case, more data, I think it will become way more better than the existing solution. I think the same analogy is the autonomous driving. Initially, they worse than human. Now they can be a little bit catching up. But in the future, as they get more data, they can outrun us in terms of safety and reliable thing. I think the same thing is in the future production system. If we are able to scale up this system, get enough data and enough user case, eventually they will show huge advantage versus the current system. Yeah, that's the way I see this two system. Yeah.
That's amazing.
That
Yeah,
makes
I
a lot
didn't
of
think about
sense.
the customer support side of things and getting customer feedback and being able to iterate, because then you don't have all the inventory on the market. You don't have to, do, have long like version redesigns and everything. You can tweak on the fly and make a better product as, information comes in. So,
Yeah. I think that I like you mentioned the inventory and the shipment issue, right? Nowadays is made in one country, shipped overseas to North America, and they distribute over the nationwide, by truck, other vehicles. And if we have a distributed production system, that printer could add your living room, right? Let's
yeah,
say one day the technology is fully mature, we can save a lot of time, not to waiting the order, the shipment, save your time, right? And save the cost. Because if you look the 3D printing process, by first principle, it consumes less material because it doesn't do any waste. Second, it does not consume more energy because the system is very efficient. I think third thing is if we avoid the overseas shipment, we avoid all this inventory, we avoid this all the return thing, and we also save our environment before we're talking about the recycle. That is a huge reduction of the CO2 emissions in that regard.
very
I
interesting.
have a bit of just a curiosity. The future's now, right? Things are changing. How will this change shopping? That's one question. How are we going to shop moving forward? And then frankly, if we get to the point where everyone has a 3D printer the way they have a microwave or a dishwasher, how do you protect or prevent, let's say, knockoffs, or if they get the file of something and they can just print it themselves? How does that change the game with IP as well? What's your prediction on all that?
So I would say I see two very good questions. First is how this change shopping. Second, how does it change the IP, right? I think I have a limited imagination. I have to acknowledge that. But in terms of shopping, let's say there will be some transition time. I think for some product, like the phone case, for example, right? I think for this product, you don't need to buy, right? Oh, sorry, my iPhone talked to me. And it's not very happy, but the case is very personalized stuff. You can put anything you want there, so that can be fully 3D printed. Even current technology can support that, right? Some TPU with the customized, personalized printing figure, that's totally doable. So if we're using that as a case, at least in the future, some item could be fully self-manufactured in your living room or in your kitchen, right? Second thing about the IP, if some great design, the file get leaked, it has been flow around in the community, everybody download. How do we protect the IP? I think that's very, very good question. Actually, I just chatted with my friends about this issue a few weeks ago. I think some bad thing could happen. I think some good thing could happen, because if you have a design file either steal or shared by many people, it means it itself have very high value, right? And how do we build a system to allow people share and use it and give the owner or creator a fair share of return? I think that is the system we need to consider to build. I think there's a technology already there, is the blockchain. If somebody come up with the original design with just a blockchain, stamp it, another clever people have some modified, a minor modify in the corner of the design. People like it, there's another stamp, right? And then certain people do the same thing, so you have a branch. If any endpoint of the branch, the thing is printed, we should have a system to monitor that. And I think any contributor in that along the chain, if they have a way to get a reward, I think that's a good thing. That will make the whole creation community more prospect and more active than before, because you don't need to be a famous designer. You don't need to have a big company, a big brand that back you up. You can just create, share it, and the blockchain will protect your ownership somehow.
That's cool.
I love that.
Yeah, I can see that kind of like what NFTs were originally intended for music, artists, etc.
Yeah, I think NFT by the essence, is a digital asset. Should be very easy connect with the digital driven manufacturing method. And not just the 3D printing. Do you guys heard of like a 3D knitting? This is the knitting machine. They can make a garment, sweaters, they claim there's no sewing point. You just give them the design you want. The whole sweater could be printed like you're printing on paper, basically. And there's no sewing point, and everything just looks like one piece. So if we see more such technology available, I think NFT blockchain is not just become a concept in the digital world. It can have impact in the physical world. And I don't know where is the physical AI in this space, but they should find a place, Yeah.
Amazing. All right. Well, Eugene, I'm going to start wrapping us up here, and a couple questions I have for you right towards the end. Our community, we have a lot of developers, a lot of engineers, and topics like 3D printing, manufacturing are always some of our most popular topics. So, for our community, if somebody was interested in learning more about additive manufacturing and physical AI, where would you recommend they start their journey?
Well, if you want just to get the knowledge and the information, I think online there's a lot of forum, a lot of information ready for people to review. But if you want to have some hands-on experience, based on my knowledge, I think the best place you can get started is the local community, creation center, right? Or even
Space.
local local place. they have an open public place, allow people to use their shared printer. And usually this is the taxpayers' money. They also have the expert and the technician, very experienced, and have a lot of knowledge about the printing. And that's the best place, I think, to get started first.
Yeah, absolutely. That's a great point. A lot of libraries are now having like they call them the library of things, where you can actually check out, 3D printers and get information on them. So,
Yeah.
yeah, getting your hands on and trying it out for yourself, I think, is a great
Yeah.
great place to start.
Yeah, for the printing technology, like what we are using now for Fitasy shoes, I think is an industrial level printer itself is so big and the investment is so big, and it have this supporting system like air compressor, industrial cooler. So that's not the easy one to get hands on, but the local community center could be the place to get started very easily. And if you like it, I think you can buy a relatively price friendly one like FDM, put it in the garage, and a lot of fun with them. Yeah.
Very cool. And if our community members want to find out more about your shoes and your product, where should they go?
I would say the best place to know our company probably is our website. Is Fitasy, FITASY.com is our website. It almost have every aspect knowledge about our company. Nationwide, and now we have 6 collaborating retail store from New York to Florida
Oh,
to
wow.
San Francisco, and also to Dallas. So I think that a place will be pinpointing our website. So that's a place you can directly experience our standard size shoe, to touch the material, to feel its comfort and the cushion level. Yeah, that will be the 2 places I will recommend to get started.
Very cool. So you all heard it direct from Eugene. Go to fitasy.com to learn more about his product. And Eugene, thank you so much for your time today and coming on and sharing your knowledge with us.
Thank you, Jason. Thank you, JC. Yeah.
Yeah, Eugene,
All
I
right.
just want to say thank you again. And what an inspiration, man. Really cool to go from meeting you at a booth right there in Las Vegas to now having this podcast episode and getting to know a little bit more about like yourself and the inner workings of your mind. Really cool. Thanks for your time, Eugene.
Thank you so much. Thank you, Jason, JC, for giving the opportunity for me to share more about the company. And I think some conversation could be very geek, hopefully. That's okay, right? Yeah.
Absolutely.
Mhm.
That's how we bonded. We were geeking out. That's really what it was. That's the intro.
Yeah, you remember our colleague Bobola. She warned me, don't be so technical and so boring to people. I say I hear you. I hear you.
This is
Yeah.
a safe place, Eugene, to geek out.
Absolutely.
Yeah.
Cool.
Thank you so much.
Yeah, thank you too. Yeah, have a good one.
This podcast is brought to you by Human Studio. Human Studio is an award-winning design studio specializing in web design, branding design, video production, and so much more. We'd love to help you take your brand to the next level.
Thank you for listening to the Tech Connect podcast. Don't forget to stay connected and explore more at www.socaltechforum.org. We'll see you next time.